Are we starting with? I like never.
Okay. A warning, this side of the building, like this set of rooms, is always freezing cold. So those of you closer to the windows, it gets colder. It just doesn't keep in here, period. And I have a little space heater, but I give it to the child development, but there's little tiny kids freezers and tiny ones off. So you guys know how to wear clothes and like bundle up. You might want to keep your like big heavy coats. Anyway, all right. So today is homework review day, and there is hopefully the easiest and shortest exit cards today. Well, there is an exit card, and hopefully it's short and easy. I was asked to do 27. And what was your strategy to start?
It's 1 divided by cotangent, so it like flips, so it's sine of, or it's cosine of. It would be cosine of over sine x, so then you flip, so it's sine x. It's like
Okay.
switches.
So one step at a time. I see 1 over cotangent as tangent. And then you said tangent is whatever what?
Sine over cosine.
Sine over cosine.
Yeah, that's what I did.
So the u value is normally the numerator or the denominator? Which one?
It's just like the
Denominator. Because we multiply by the derivative of the thing inside. So if the top is, because the top is where the chain rule thing is going to be. So if u is cosine, du is negative sine 3x, then chain rule.
Yes. Yeah.
So cosine 3x is the u value. Then sine 3x dx, which is all that's left, is negative 1/3 du. And putting the x values back in, ln absolute value of cosine 3x plus c. And I think absolutely none of you remember that we did this in previous section, but I said the integral of tangent is natural log of secant plus c. And I also said, when we get to chapter 6 and we do use substitution, I'll just show you these. They're not the same. Well, this problem was tangent 3x. So that would be ln secant 3x. And chain rule would have been multiplied by the derivative of the stuff inside, but we're going the other direction, so I divide. It's closer, but still different. Why is it different? That negative comes in as an exponent. 1 over cosine is actually secant. Now they're the same. And in the land of memorizing, I was like, tangent and secant are always friends, they go together. And it helps in continuity of remembering stuff. But doesn't matter. Except if it's multiple choice and they have the answer as secant and you've got an answer of cosine. What else from the homework of the last few days? Yes? Yep. Which you were like, the first night I did not assign, but put it on last night's. So the hint was always, the U value is the thing in the denominator, the thing being raised to a power, the thing that's isolated. That does not apply here. You gotta like kind of see. Does anybody see what the U value should be? Sasha?
ln(x),
ln(x). And why did you pick that?
because the derivative of ln(x) is 1 over x, which is the other thing involved.
And it's hard to see because they're both in the denominator. Okay. ln(x) becomes u, but dx over x, which is all that's left, becomes du. I need to trade the bounds. Annie, how do I change the bounds from e to 6 to numbers in terms of
Replace u with the
So when x is e, what is the u gonna be?
1.
1.
I just left the other as ln(6).
I mean, that's all you can do. You can't, I mean, it would take a calculator to get a decimal approximation. Gus, what is the integral of 1 over u?
Natural log.
Wait, hold up. I thought 1 over.
What's your question?
Oh, my God.
So natural log is the absolute value of u evaluated from 1 to natural log of 6. Roxana, how do I plug these things in?
I just plugged in ln(6) to get ln absolute of ln(6), and then if you plug in 1, it's just 0. So I just left it.
Minus ln1, she said, which is just 0, so I'm gonna leave it alone. Natural log of 6 is positive, so I don't actually need the absolute value bars, but that's it. Natural log of natural log of 6. It's just, yeah. What else?
In 23, in like the textbook, they never changed the interval. So I'm confused why they never like plugged in x for u and switched it.
They should have. Did they say x equals on the thing? Okay. Don't do that.
So I should just plug it in.
Camden, which should the u value be chosen in this problem? The sine or the cosine? Sine. Derivative of sine is cosine. So Ari, how do I swap things out?
Just do 1 over u.
1 over u du. And then Brooke was saying the book didn't show this step. Sine of pi over 4, root 2 over 2. Sine of 3 pi over 4 is also root 2 over 2. Ooh, gross. 1 over root 2, 1 over root 2. Area under a dot is 0. Or you could have reverted back to things and done the not very smart way that the book evidently showed.
I don't understand. Like, I need to write all this concept down, like how to do this.
So what can we help with?
Find.
So in each case, figuring out what the u value is, often it's the denominator. Why? Because I see the derivative up top. This one, cotangent, I needed to split up into its trig friends. And again, I'm picking the denominator because the derivative is up top. This one was hard. Sasha said just that part of the
You find a u, then you divide by the derivative of u, and then you use the integral of that.
We're not exactly dividing by the derivative of u. We're translating everything.
Like excluding it.
Okay, so let's. Amir, which one of these do you wanna try? Like, should we look at?
Tangent x secant squared x dx. So I think you would be tangent x. And the
Where is that one? What number?
number 13, I think.
33, okay.
No, the square roots of, fine, whatever, so the u is tangent x, and so the derivative of u is secant x squared, so we can, so like, do we exclude that? Do we, like,
Okay, it's not excluding. So you said u is tangent x for this problem. The derivative is secant squared x. Cool, great. So we need to just translate. To write it again so that we can see it in process. You selected tangent to be the u value, so I need to change that. That's now u. The things that are left, those still need to be translated. So Amir, what's left to be translated is secant squared x dx. Looking at the setup, what is du?
secant squared x dx?
So can I pick this stuff in the purple square out and put in du? Is it a fair exchange?
So you like integrate it, like,
This is not integrating, this is just translating from miles per hour to kilometers per hour.
okay, so
I took my 100 pennies and I got $1, because $1 is
so
cleaner.
after that, like,
Okay, we're not done, but are you okay with this step?
Yeah.
Okay, so the next thing, do I have bounds? Do I have numbers on that integral
yes,
symbol?
you do, you have negative pi over 4 and 0.
Okay, so those are x values. I need to make those also into,
Well,
how do I translate those
plugging them
numbers?
into u.
All right, so do that.
Okay, so negative pi over 4 is negative 1. And 0 is 0.
Okay, so this stuff that was the original problem, ugly, crazy, all kinds of nasty stuff, it has now become simplified. I took 100 pennies and made $1. They're equal, but this is easier. How do I integrate? Now we're integrating. How do I integrate you?
So, it's like a tangent, yeah.
Nope, this is gone.
Secant squared x,
Nope, this is gone. Integrate the thing we just translated, right here.
what? This one,
Just integrate,
you,
how about this?
what? The frick?
Don't look at u's, don't look at tangents. How would you integrate x?
F of x.
Not f of x, just x. Power
X
rule.
squared over 2.
Thank you.
Okay.
And then evaluate it from 0 to -1. So plug in the 0 first, 0 squared over 2 minus -1 squared over 2. That comes out to -1/2. That is exactly the problem we have here, except they didn't call it x, they called it u.
Okay, so reverse power rule to tangent.
Raise the power, divide by the new power. Amir, tangent is gone. It is dead to us. We have changed it into u
What
values.
happened to tangent x then?
We changed its name.
Fine. Fine, whatever.
We changed its name to make it easier.
Okay.
Yes.
If the bounds were going like the other direction in the beginning, should we just flip them and put a negative in front?
You can do whatever you want. You can flip them or you can deal with the negative, like however you makes sense to you best. Alex?
So we only need to plug what we set u equal to back into the equation if we're not finding it. Like,
If it's not, if it's got numbers, you don't need to go back to x's.
Okay.
If there's no numbers, I need x's back.
Okay.
Are we okay with 35? The reason it's circled is it's a traditionally highly asked question. I mean, to me, here the u values stand out. not the entire denominator, but the thing being raised to a power in the denominator. Why? Well, the derivative of 1 goes away. The derivative of theta to the 3/2 multiplied by the power, lower the power. Do I have the square root of theta up top? Yes. So some form of the derivative is there, in particular the variable. It's off by a constant, whatever, I can fix that. This guy, the u value is the thing under the square root. Why? Because the derivative of it is pretty much sitting right there. And so Roxana, you asked, well, what if we can just see what the integration is? Can you guys see it in 31, or do we need to do u substitution?
Oh, well, U substitution would work.
Yes, u substitution does work, but like, let me try this. I'm gonna leave it as this. I'm not gonna do u substitution. I'm gonna raise the power, divide by the new power, which is dividing by 3/2 is multiplying by 2/3. And I'm gonna, the point of u substitution, divide by the derivative of the stuff inside. Hadley, what is the derivative of the stuff inside? 1. Okay, so there, I divided by the derivative of the stuff inside, and now I'm gonna evaluate from 0 to 3. So it's 2/3, plug in the 3. 3 plus 1 is 4, square root of 4 is 2, 2 cubed is 8, minus, plug in the 0. Something like that. If I do u substitution, I get the integral of the square root of u du when x is 3, y is 4, or when y is 3, u is 4, and when y is 0, u is 1. Raise the power, divide by the new power, and evaluate from 1 to 4. I get the same thing. So after a while, you will get more comfortable with these, and if it's just a constant, like chain rule, that just became dy. It was a 1. I can integrate that without doing things, u substitution. These guys, if you're dividing by like variables, things with x's in it, you need to do the u substitution process.
I think I'm ready for the exit card.
Was number 9 assigned?
Okay, so U is equal to 1 minus x du is negative 1.
Okay, can you guys try number 9? Yeah, no, this is
U equals dx. Okay. Negative equal 1 over u squared du. Is that correct? The form is 1 over u squared times du.
What did you choose as u?
1 minus x
So du is,
negative 1. So negative du is dx. Oh. So that would be
so
negative.
Martin, how do I integrate negative 1 over u squared?
Well, it's 1 over e because you raise the power by 1 and then you multiply by 1.
Okay? So raise the power from -2 to -1, dividing by a -1. So it was -1 over u, then dividing by the negative, he's like, well, then it just becomes positive. I'm forgetting something? plus C. No bounds, so I need the plus C. Do I need to, Alex, do I need to go back to the X's or do I stop here?
In this case, you do.
In this case, I need to go back to the X's, so it becomes,
How did it become positive?
how did it become positive? My comp said, raise the power from -2 to -1, divide by the new power. And don't forget the plus C.
I still don't understand how it's negative.
How this became negative in the translating.
Oh, it's not, oh, I see.
Evidently, I can't make it come back. Because Amir did the derivative of U and got -1.
And you want to re-substitute the x's back in for you because we don't have numbers here. But
Correct.
if we
I'm
did have
asking for a
numbers-
function. Give me the function of that.
But if we did have numbers,
You could just
oh
plug
yeah,
in,
you could just plug in once you.
once you translated X
the
bounds to U bounds, just go through there.
Okay.
Is 17 scary? Gus, you look pensive. Like, my hints are always, it's the thing in the denominator, it's the thing being raised to the power, well, the thing being raised to the power is in the numerator, and there is a denominator. So I'm conflicted.
Oh.
I hear you.
Huh.
Which one is the U value?
Which number?
17.
Okay, so the thing is,
Someone says 1 over x, and someone else says ln x. One of them, I mean, it's one or the other. It's not ln x to the 6th.
Ln
Why that?
because the derivative is 1 over x dx.
Because its derivative is just 1 over x. So in this case, it's the thing being raised to the power. So Clara, how does it translate? How does it translate all this X business to business?
U to the 6 du.
So the entire denominator goes away. So Jamie, how does that now integrate?
U to the 7th over 7 plus C.
And Aton, to bring it back to what it was originally?
Plug in ln x for you to get the 7 over 7 plus c.
And you can put the 7 outside like that. If you do that, you need parentheses, otherwise the 7 is going on the x, which is different. Or you could write it up there.
okay, so like, so if you multiply by du, so that removes, you cancels out x if you multiply by du.
Doesn't cancel out x, but dx over x gets removed, and that, we were told, equals exactly du. So we're gonna get rid of these guys,
Okay,
and we're gonna call it du.
okay, gotcha.
Yep, it's an indicator that you chose like the wrong thing as U if it just doesn't work or.
Yeah, if
it's
it gets
just
ugly.
kind of too-
So if I choose 1 over x or x, which would, okay, let's
You
say,
choose X, not Y. Or wait, in this case.
if I choose 1 over x, the derivative of that, am I anywhere close to replacing the ln? Like, no, like really bad, no. So if it's not looking like a good path, cut and run. The first day of stuff, was asking me to integrate successively, like over and over again, and get the constants. So just to show you one example, 37, they gave you the triple derivative. Okay, integrating the triple derivative is here. Raise the power, divide by the new power, add a constant. Then it gave me the value of the double derivative at 1 is 2, so replace the double derivative, its effective y value, and the time value, solve for that constant. So my double derivative was negative 1 over 2 t squared plus 5 halves. Integrating that to get the first derivative. Second derivative integrates to the first derivative. Raise the power, divide by the new power. This guy gets a new variable and it gets its own constant. And it told me the first derivative at 1 equals 3. So solve for the c value there, and I got 0. Cool, that was nice of them. And then integrate the first derivative to get the function. So 2 nights ago, 3 nights ago, whatever it was at this point, was just asking you to keep integrating, don't forget c, don't forget c, don't forget c. And plug in and solve.
On like the one that says d squared y over dx2, there's a negative on the negative 1 over. Oh wait, when you integrate.
And then integrate, raise the power,
Yeah, got it.
which goes from negative 2 to negative 1, dividing by the new power.
Yeah, I didn't see the other part. I thought it was just.
I tried to make it when it changes colors, I've integrated. Okay, yeah.
For like number 19 on this, it's like the integral on 5 secant squared 5r, and I'm just wondering like, and with the text, I'm thinking like you have to divide by the 5 in the front after you get the 5 tangent to 5r. Like similarly to how you have to do like cosine or like sine, it's like 5x or like something like that. What are like the situations where you have to divide by the
Okay, first of all, like, this is one that I can do without u substitution at this point because I recognize things, but if you're uncertain, I'm gonna call u I don't know, 5r. So du is 5dr. So it's secant squared u, and 5dr is du. Whose derivative is secant squared? Tangent. So it's just going to be tangent of u plus c. Plug stuff back in, it's tangent of 5r plus c. So Millette, I see this as, okay, whose derivative is secant squared? Tangent of what? Of that stuff. And then undoing chain rule, when I did the derivative, I would have multiplied by 5, so chain rule, I'm going to divide by 5, so that 5 out there got divided again and it goes away, and keep the plus c. So after a while, you guys will get comfortable with those that are just a constant, and you'll be fine with them. Other questions? Throughout the year, I want to show this, and then I'll give you guys the exit card, of which you'll have way too much time. But height. Integrating cosine squared or sine squared, we can't do that. Secant squared, yes, but these guys, I don't know. And because I teach pre-cal, I use this all the time. Anybody remember the trig identities for the double angle for cosine? I know, it's random.
One plus cosine 2x over,
The hint that's covered up is based, Kelly, what are you,
cosine squared x minus sine squared x.
okay. So I generally do the proof of this, and it uses law of cosines and Pythagorean theorem, and you get that. That version, that's the one that pops out of the proof. Not helpful at all. But I know that sine squared equals cosine squared, so swapping that out, I get that form, or swapping out cosine squared for sine squared, I get this. Why is that helpful? Well, right here, cosine 2x plus 1, all of that divided by 2 equals cosine squared. I can't integrate cosine squared. I can integrate this. Preston, whose derivative is positive cosine? Positive sine. So this is sine. I'm going to leave the inside stuff alone. And then I need to divide by the derivative of the stuff inside. And this guy integrating 1/2, well, that's going to just become 1/2 x and plus c. So I use these trig identities from pre-cal a lot. Yes?
I'm sorry, how did you just do that, like the second step, not like the middle portion where you went from cosine 2x plus 1 divided by 2 is equal to cosine.
How did I get that identity?
Yeah, no, I got the identity part. I mean, like, how did you, like, my brain's just not, like, connecting to two very well.
Okay, it's morning. Okay. U is cosine 2x. Sorry. U is 2x. Yeah? So translating, that's going to be cosine u. I'm just looking to deal with that. I have the 1/2 there. So the dx is 1/2 du. Yes? Whose derivative is positive cosine? Preston said positive sine,
Oh, yes.
and then putting the 2x back in, I get sine 2x over 4, integrating 1/2. Just get that x, and then plus c. All right, can you guys clear your desks, please?